This presentation is provided for information purposes only. Users of this information are doing so at their own risk. Fortis Alberta does not endorse the services or products of any specific consultant or contractor referenced in this presentation. Fortis Alberta will not be held liable for any loss or damage in connection with the use of these consultants or contractors, or any information provided in this presentation. Fortis Alberta acknowledges that its operations and facilities occur on the traditional territories, meeting grounds, and traveling routes of the Indigenous peoples of Treaties 6, 7, and 8, and Métis people in Alberta. We make this acknowledgement as an act of reconciliation and gratitude to those whose territory we reside on or are visiting.
So, why are we here today? Studies show that approximately 25% of greenhouse gas emissions in Canada are from the transportation sector, and the federal government has created some ambitious goals to combat this, like 100% zero-emission vehicle sales by 2035. To support those vehicles, they aim to have at least 50,000 electric vehicle chargers nationwide by 2026. We find ourselves at the precipice of innovation and adoption. Will there be more EVs on the road with improved availability of charging opportunities? Or will charging demand increase once more EVs are on the road and rise to meet it? The proverbial chicken and the egg. Here to help us understand the importance of deploying electric vehicle infrastructure is Peter Casarella. He's going to explain why it's a good thing. And to give us some context as to the type of charging equipment that is available on the market and what trends suppliers are seeing, we're joined by Hypercharge representatives Mac McWilliam and Rory Gattens. To talk funding available to purchase that equipment, many of you have already been introduced to Logan Holan from the Municipal Climate Change Action Center. And lastly, once you have the equipment, Jack 2 from Fortis Alberta will run through some of the costs you can expect post-installation. And you'll get to see my smiling face again to chat with you about how to get that installation started. With that, I am going to turn it over to Peter.
Thanks, Jennifer. Yeah, my name is Peter Casarella. I'm the Executive Director of the South Grow Regional Initiative. We're one of Alberta's 9 regional economic development alliances here in Alberta. I live in Lethbridge and I work for 30 municipalities down in the south end of the province. I'm on here because we're the administrator of the funding that you're going to be hearing about from Logan later on. And we've been involved in EV charging infrastructure deployment since 2017-ish. We were involved in the Peaks to Prairies project, which was Alberta's first large fast charging network that was deployed across southern Alberta from Banff down through Medicine Hat, covering the entire southern edge of the province here. Just to give you a brief overview, Jennifer mentioned a few of the trends that are going on, which kind of explain why economic development is interested in helping to roll out this kind of infrastructure. She mentioned the mandates coming from the federal government. By 2035, 100% of the electric vehicle passenger sales in Canada have to be, 100% of passenger vehicle sales in Canada have to be electric vehicles. We're on an aggressive timeline there in order to meet our climate change adaptation goals. This means that on the ground, about 3% of the vehicles on the roads in Canada by 2025 are going to be EVs or plug-ins of some kind. By 2030, 11% are going to be plug-ins. And by 2040, you're going to see about 60% of the vehicles actually on the road will be plug-in vehicles of some kind or another. That's a huge percentage, and it's a very, very rapid industry transition. It's not as fast as industry has transitioned in the past, though. In 1908, the Ford Model T rolled off the production lines for the first time. And it was about a 13-year time span between those first mass production private vehicles coming off the line to when practically everybody who had a private vehicle was driving an internal combustion engine vehicle rather than a horse and buggy. That was massive industry transition. It was a pretty big step up from the horse and buggy, but it involved the rollout of infrastructure everywhere in order to accommodate that. And communities across North America were really, really eager to get service stations in place, just like we're working to get EV charging in place. Because as soon as it became apparent that this was going to be an important part of the game, if you didn't have the infrastructure to support the travel medium that was being adopted by everybody, then you were out. Nobody with that kind of vehicle would come to your community to shop, to do business, or there was problems and barriers to them being able to do so. So part of this really is making sure that we're keeping up with the rest of the world. And what I mean by that is we're way behind the trend. There's a reason why Albertans don't necessarily look at this as like a big thing in front of mind. It's because we're at the back end of adoption. If you look at Europe, there's over 5.6 million plug-in vehicles across the continent. In China, there's even more. There's over 8 million EVs on the roads in China right now, and we're trailing on the edge of adoption. But all the trends indicate that we're going to be following suit with the rest of the areas of the world that are moving in this direction. EV vehicles have come of age. The range is getting really, really good. The charging times are going down, and they make an awful lot of sense. They're here to stay. So what's the opportunity? Well, charging stations attract customers to your location. If you don't have them in the near future, you are going to be out, so to speak. You won't have the same opportunities that other communities do when there's something like, 30, 40% of the vehicles on the road are EVs, and they need to have a charging option in the community or at your business or local, someplace around where you are at. And there's a growing market. Grants are available now to offset your capital costs. So if you're looking at having to implement this kind of infrastructure eventually, right now in this immediate moment, you can actually get grant funding to help you offset the capital costs, and that's not going to be the case forever. Governments typically incentivize new technology that they're hoping to encourage people to adopt with grants at the beginning of the adoption curve. But once it becomes clear that this is where it's going and the business case becomes more robust, then the grants go away because the government's like, well, people are going to do this anyways. We don't have to put public money into it. So this is a good opportunity to jump on it and to reduce your own capital risks. And the other cool thing, too, is that we're seeing in places in Europe that EV chargers are already overtaking gas pumps in profitability. So basically, your input costs in order to run an EV station, to build it, to service it, to maintain it, are a lot lower because it's an electrical connection. You don't have to have tankers come in and dump a whole bunch of fuel into the ground. You don't have to deal with complex pumps and stuff like that. It's a lot easier to maintain, it's a lot cheaper to run, and the cost of power is pretty low. And there's lots of interesting ways that you can offset the actual power that you are feeding and selling to people who are charging at your station as well. So in the long term, profitability is quite good compared to traditional gas pumps. Obviously, the adoption curve as far as vehicles on the road has to accelerate till we get to that point of profitability. But once again, grant funding now to offset your capital costs. So that's the reality of the world that we're looking at and that we're living in. Happy to answer any more questions on that later on, along with my fellow presenters. But I'm going to pass the mic down the road now to Rory and team.
Thanks so much, Peter. Sorry for the delay there. And to introduce myself and Hypercharge, my name is Rory Gattens. I'm a sales and partnerships manager for Western Canada for Hypercharge Networks. And what Hypercharge is we're Canada's only publicly traded EV infrastructure company operating across North America. So we have offices in both Vancouver and Toronto to serve our customers, where all of our product, our spare parts, and our customer experience and network operation team reside. So, the mission of Hypercharge is really to provide turnkey smart energy solutions to help our partners grow their business as we shift towards a carbon neutral economy. And, we're a technology innovation company that really listens to our customers to provide consultative expertise around right-sizing hardware, to right-size infrastructure to allow for additional charging stations in a location as adoption increases, and really listening to our customers around their preferred model of ownership and their budget in order to provide a comprehensive solution. And again, we provide a cloud-based platform for station owners to manage their stations in public, whether that's to limit access control on who can use the stations, in addition to broadcasting to the general public where the charging stations are, if they're in use or not, and also if they have to pay to use that service. In addition to that, we provide comprehensive hardware ranging from 6 to 350 kilowatts and provide the proactive support services to manage those stations in real time. Again, like I mentioned, we offer charging solutions ranging from level 2 to level 3 infrastructure. So this is very pertinent for anywhere you can potentially park your car, whether that's in single family homes, multi-unit residential buildings, workplaces, fleets, or charging in public at retail locations or gas retail locations where there's high-powered DC fast charging infrastructure. So the question always is why do electric vehicles work? Where, firstly, there's lower emission savings to reduce the operational costs in owning and operating a vehicle And in addition to that, it reduces a individual or organization's carbon footprint. So, electric vehicles are a lot more efficient than the traditional combustion engines, which is a higher efficiency with the battery motor. As we know, there are lower fuel costs associated with electric vehicles versus traditional internal combustion engines, in addition to the decreasing battery costs, which are making electric vehicles a lot more affordable for the everyday driver. Now, lastly, which is very relevant both from a personal perspective as an owner of an electric vehicle, but also as we see the larger transition of workplaces and municipal fleets, is there's less maintenance associated with electric vehicles, where there's a lot less moving parts than the internal combustion engine vehicles. You have to do your typical maintenance like rotating tires, replacing fluids, changing cabin air filters. However, the brake wear is significantly reduced on the vehicle itself due to regenerative braking within that vehicle. And as Peter alluded to on the EV charging infrastructure side of things, infrastructure is the priority, where to meet the demand set out by both provincial and, more importantly, federal governments for zero emission vehicles in the future, again, we're going to need to be able to support that through public fast charging infrastructure, in addition to public level 2 infrastructure, where, again, I'm referring to different charging connector types. And to give you an overview of the EV charging connector types and the levels of charging, there are level 1 and 2 charging stations, which utilize a J1772 connector, which is compatible with 100% of electric vehicles, in addition to Teslas being able to use this with an adapter. So this is typically used with your traditional wall outlet like you have in your home. There are also fast charging infrastructures and connectors, where there is a CCS connector, which is for more level 3 fast charging infrastructure, which is compatible with the North American and European automobile manufacturers, where Teslas can actually not utilize this connector. As we move into the CHAdeMO connector, this is typically for Japanese automobile manufacturers on the level 3 fast charging side. And again, Teslas can actually utilize this connector with an adapter like we're seeing across North America. And the last charging connector type I wanted to highlight is the Tesla connector, where you're likely seeing Tesla supercharging infrastructure across Canada, and more importantly within Alberta, where only Teslas can actually utilize that infrastructure. However, now we're seeing with recent announcements that Tesla will slowly be opening up that infrastructure to the more universal vehicle types. And to speak to the EV charging types further, again, like I mentioned, level 1 infrastructure it's more typically a portable charging solution, where again, it's a 120 volt outlet. You're typically getting anywhere from 4 to 8 kilometers of range per charging hour. And again, this charging solution can work in a scenario where me as an electric vehicle driver, I don't drive very much, or maybe I drive less than 30 kilometers a day in a dense urban center where I can get away with that. However, with the larger battery sizes of electric vehicles, the typical electric vehicle driver just finds that level 1 charging is too slow. So then the next step up would be level 2 charging infrastructure, where this is installed on 208 or 240 volt. Again, it is a J1772 connector as well. It ranges on the kilowatt output depending on the station itself, or if stations are being load share on the same circuit. And what that means in terms of kilometers back into an electric vehicle is about anywhere from 30 to 100 kilometers of range in a charging hour back into that electric vehicle, which is depending on the output of the charger and also the electric vehicle's battery size. So level 2 charging is great for overnight charging in residential households, in multi-unit residential buildings or apartment buildings, where an electric vehicle is stagnant from anywhere from 8 to 12 hours overnight. In addition to this, we're seeing level 2 charging popping up in public spaces, in commercial parking lots, in addition to public parking lots. And level 2 charging is great for workplaces or fleets who do have the ability to charge overnight for a longer period of time. Now, more relevant to the presentation today is level 3 fast charging infrastructure, where we're seeing these fast charging stations pop up in public, at arenas, community centers, at sporting events, in addition to gas retail locations and highway rest areas, where these stations are installed on either 208, 480 volt, or 600 volt. And depending on the station, it has an output of 24 to 350 kilowatts. Typical stations you are seeing do have both CCS and CHAdeMO connectors on the stations themselves to allow for any electric vehicle to access the service, whether you're purchasing a Nissan or a European automobile manufacturer like a Mercedes or a Volkswagen. And again, with these fast charging stations, they're great for on-the-go charging, where typically you're able to get about 80% of the vehicle's charge in 30 minutes or less, depending on the electric vehicle's battery size, in addition to, the state of that vehicle when it does approach the station itself. So again, just to give you food for thought around, the types of charging types and where these types of charging stations do come into play. But again, on the level 3 fast charging side, they're great for on the go where I'm making a large trip, or if I'm not able to charge at home overnight for my next day's commute. And I will pass this over to Logan. And again, like Peter mentioned earlier, looking forward to any questions you may have towards the end of this presentation.
Thanks, Rory. Yeah. Good morning, everybody. My name is Logan. I'm a project associate here at the Municipal Climate Change Action Center, and I'm just going to take the next 10 minutes or so to overview some funding that is available for level 2 and level 3 EV charging stations through the South Grow Electric Vehicle Charging Program. Just before we get started, a little bit about the Action Center. The Municipal Climate Change Action Center was founded in 2009 as a collaborative initiative between Alberta municipalities, the rural municipalities of Alberta, and the government of Alberta. And we provide funding, technical assistance, and education to municipalities, nonprofits, and schools in helping addressing and combating climate change. Just briefly looking at our impact, since 2009, we've completed around 721 projects with 389 unique participants and helped mitigate and avoid around 726,000 tons of CO2 and catalyze around $155 million in clean energy savings. Just looking at the South Grow portion of this presentation, we'll look at the program status, so kind of where it's at right now, the funding that is currently available and how it's structured, the application eligibility, what are the application requirements, and the participation timeline for the South Grow program. So looking at the South Grow program specifically, South Grow, the regional group, has received funding from Natural Resources Canada through the Zero Emission Vehicle Infrastructure Program to help deliver funding here specifically in Alberta to help with the purchase and installation of level 2 and level 3 EV charging stations. And this program is being delivered in partnership with the Municipal Climate Change Action Center. Funding for projects is currently available province-wide for a variety of applicants, which I'll get into here in a second. And there's still currently a significant amount of funding that is available. The application deadline is approaching, so March 31st, 2023, so just a couple of weeks before the program will be closing for applications. Looking at the funding levels specifically, so the funding has changed slightly. If anybody had looked at this program previously, whether that be in the summer or the fall, you may have noticed that originally this program was capped at $100,000 per applicant. However, this program has changed, so it's now capped at $100,000 per location. So that means that an applicant who owns several businesses throughout the province could apply for each business, and each would be eligible to receive up to $100,000 in funding, whereas before it would be capped at just $100,000 for the applicant. And then the funding is also based on the type and the level of EV charger that is installed. So for a networked level 2 charger, an applicant can receive a rebate that covers 46% of the costs up to a maximum of $5,000 per connector. That connector part is important. For level 2 charging stations, they often come with two connectors, and in that scenario, an applicant can receive 46% up to a maximum of $10,000. And then the amount of funding that an applicant can receive increases as the type of charger increases as well. So for a networked level 3 charger rated between 20 and 49 kilowatts, you could receive a rebate that covers 46% of the costs up to $15,000. Between 50 and 99 kilowatts, a rebate of 46% up to $50,000. And then finally, for a level 3 charger that's rated for above 100 kilowatts, you could receive a rebate that covers 46% of the costs up to $75,000. Looking at the eligibility based upon organization type. So this program is open to almost anybody except for private residences. So businesses, municipalities, cooperatives, indigenous communities, nonprofits, institutions, multi-unit residential buildings, and others on a case-by-case basis are all welcome and eligible to apply to the program, with the only group not being considered eligible would be actual private residents. Looking at eligibility and project requirements, there are several requirements that need to be met to be considered eligible within the program. The first is that the chargers must be installed in Alberta on owned or leased land. The chargers must be new, so they can't be used to replace a currently existing charger. And they need to be permanently installed and owned and operated by the applicant. The chargers need to be networked, so that means they can connect to the internet or to a server, so the owner can see real-time usage, implement a usage fee, implement scheduling, and perform updates. The chargers need to be installed by a fully licensed electrical contractor. They need to have a valid electrical permit and pass all inspections. And if the chargers are for public use, they must have a dedicated EV-only parking stall per connector. So for a level 2 charger with 2 plugs, you would need two EV-only dedicated parking stalls. Looking at a couple things that are not considered eligible. So we ask that applicants do not purchase or install anything prior to receiving approval and signing a funding agreement. I'll get into this a little bit more in a second here, the funding agreement purpose or process. But Natural Resources Canada is very specific that they don't want any retroactive costs. So we just ask that nothing is purchased or installed until everything has been signed off. The chargers need to be networked. They can't replace currently existing charging infrastructure. They can't be for non-passenger electric vehicles, such as ICE resurfacers or ATVs, and they can't be for private residences. Looking at the eligible expenses, so there are 5 specific categories that are considered eligible within the program. So the first is the cost for equipment and materials. So this is typically the actual chargers themselves, and then any breakers, cabling, wiring, anything like that. The second would be the actual installation and construction phase of the project. Third would be any engineering and design work. Fourth would be permitting and inspections. Typically with the installation of EV charging stations, you need electrical or building permits. And then site signage as well. So this could be any physical barriers, any signs located near the EV charging stations, or actual paint on the ground that clearly marks there for EVs only. And then electrical service upgrades can also be included on a case-by-case basis. Looking at some ineligible expenses, so GST, taxes, land and legal costs can't be included. Any of the ongoing and maintenance costs, So that's the cost of electricity, the networking costs, and any maintenance costs, any extended equipment warranties, and any in-house labor and administrative costs relating to participating in the program. So that's the cost of actually putting together the application, having a site visit completed, things like that can't be included retroactively within the program. Looking at the application requirements, so there are four major requirements. The first is the application form itself, which can be found on the MCCAC's website. The second is an equipment or installation quote. So this is typically completed by a contractor or installer who will actually complete the project. We just ask that a site visit is completed and all the associated costs are determined with that contractor. Third would be the charger specification sheets. And then finally, some pictures of where the chargers will actually be. Looking at the participation timeline, so the first step would be to review the guidebooks and resources that are found on the MCCAC's website. They just go into a little more detail, kind of covering everything I've gone over here this morning. The second step would be to submit an expression of interest. Once that EOI has been submitted, somebody from the Action Center will reach out to schedule a Teams meeting to go over your project in a little bit more detail. After that's been completed, you're welcome to submit the application with the application form, quotes, spec sheets, and pictures. The application isn't a pass-fail. We'll go through it, make sure everything's accurate, up to date, and all signed off. Once that application has been approved, we will then put together a funding agreement that would outline the rebate that the applicant is eligible to receive. And once the applicant and South Crow have fully signed off on that funding agreement, you could then begin the project itself. Once it's signed, you'd have 12 months to actually complete the purchase, the installation, and have those chargers operational. And then once everything has been completed and the chargers are operational, there are then a couple of project verification and completion steps. So proof of payment, some pictures, things like that. And once that's all been completed, we would then request a rebate from Natural Resources Canada for your project specifically. So just a couple things to keep in mind. The application deadline for the program is March 31st, so coming up here in a couple weeks. And the projects will need to be completed by March 31st of 2020. Lastly, I will also mention the electric vehicles for municipalities program. This program is open to municipalities only and provides rebates for the purchase of electric vehicles, plug-in hybrid electric vehicles, ice resurfacers, and off-road vehicles as well. The application deadline for this as well is March 31st. Just coming up here in a couple weeks. And that's it for the funding portion. If anybody has any questions, please feel free to reach out. And I'll turn it back over to Jack and Jennifer.
Good morning, everyone. Thank you, Logan. My name is Jack, and I'm an engineer at the Emerging Customer Solution team in Fortis, Alberta. So I'll be walking you through the new rate that we created for the EV fast charging services. So we created the rate 62 by December last year. It was approved by the AUC. So before I walk you through the details of rate 62, I'll walk you through the what we have prior to that to help customers understand why rate 62 could be of great support to customers who look to install EV charging stations. So I'll first share how the fast charging stations were typically categorized under Fortis Alberta's existing rate classes prior to the creation of rate 62. So for services without specific end-use description, such as residential, farm services, irrigation services, oil and gas services, if the service level is below 2,000 kilowatts, It is generally categorized by FortisAlberta as REIT 41 and REIT 61. So REIT 41 is for services range between 3 to 75 kilowatts, while REIT 61 is typically for services between 75 kilowatts to 2,000 kilowatts. So although few types of fast charging stations could fall under FortisAlberta's REIT 41, we expect the majority of level 3 fast charging stations would fall under REIT 61 category. So on the presentation, I have attached the REIT structure for REIT 61 as per there. So to help customers understand what REIT 61 could mean for level 3 charging stations, I'll first quickly go through the transmission and distribution tariff structures for REIT 61. So the transmission and distribution tariff charges for FortisAlberta's REIT 61 generally contains 5 components. There's the system usage charge component, the capacity charge component, local facility charge component, variable charge component, and service charge. So I'll explain each component in a bit further details. So the system usage charge component is applicable under both transmission and distribution tariff at different rate. So it is tied to customers' monthly peak meter demand. This means that for this component, customers' bills are based on the peak demand that they have used of the distribution system within the billing cycle. So if your service has a peak load of 150 kilowatts during your peak cycle, during your billing cycle, your system usage charge will likely be based on 150 kilowatts. Capacity and local facility charges are tied to customers' kilowatt of capacity, where the kilowatt of capacity is defined as the greater of customers' current peak meter demand, 85% of customers' past 12 months peak meter demand, contract minimum demand, and rate minimum. So capacity charge is a transmission charge, and local facility charge is a distribution charge. For these two demand charge components, your historical peak demand and contract demand will play an important factor in your bill. Assume if you have a current monthly peak of 100 kilowatts. However, if you have another higher peak demand in the past 12 months, let's say 200 kilowatts, then your bill would be based on 200 kilowatts times 85% factor, which is 170 kilowatts. So the variable charge component is tied to your energy consumption and is a transmission charge. This is fairly straightforward. This charge is based on how much kilowatt hour your service has consumed during the billing cycle. The service charge is a fixed charge on a dollar per day basis. Again, this is fairly straightforward. So it's the fixed cost from FortisAlberta to provide the billing, IT, and administrative services. So generally, a great portion of customers' charges under REIT 61's transmission and distribution tariff would be demand components related, and that is tied to the system usage charge, capacity charge, and local facility charge, which means these charges are related to customers' peak meter demand, historical peak meter demand, and contract demand. So what concerns would REIT 61 create to the customer who want to connect EV charging infrastructures? Our understanding is it will create uncertainties to customers from primarily two perspectives. So first uncertainty is that customers may still experience significant distribution plus transmission charges, even with low utilization of the charging station. As currently the EV adoption rate is still fairly low in Alberta, a charging station located at a relatively remote area isn't likely to be utilized too often. However, even if only one car charges per month and triggered that peak meter demand, customers will need to pay for that peak meter demand based on REIT 61 tariff structure. In addition, assuming the following months there's no car charges at the station, customers will need to continuously pay for the past month's historical peak through kilowatt of capacity charges. And second uncertainty to the customer is customers don't know how much contract power they need to contract with the utility and how many cars could be charging at the same time. If a customer only has one fast charging station installed, it is fairly simple to decide the contract demand. However, if customers had multiple charging stations, then it becomes complicated to decide how many cars could be charging at the same time and what is the power they're likely to withdraw from the grid. That impacts customers' decisions on contract demand that they were willing to do with the utility companies. In addition, the uncertainty of charging pattern could also impact and violate customers' historical peak meter demand as well and create uncertainty in customers' bills. So with deep understanding of customers' concerns to connect fast charging stations economically, and with the considerations that the EV fast charging station customers may be a set of customers that do not fit in within the homogeneous structure of existing REIT 61, Fortis Alberta has studied the charging stations in its service area, including their energy consumption, load usage pattern, and load factors, and proposed the interim REIT 62. REIT 62 is expected to help reduce the economic barriers for customers to maintain the power services of Level 3 fast charging stations, and to help Fortis Alberta understand customers' charging patterns to effectively satisfy customer service requirements and to better plan the distribution grid in an economic and efficient manner. It is applicable to a maximum service size of 500 kilowatts. So with REIT 62, it is expected to be an interim measure to support standalone public EV Level 3 charging stations while the utilization is low, and to reduce the charging desert in remote locations. So under REIT 62, besides the fixed daily service charge, customer pretty much pays for the transmission and distribution tariff for the charging station on a pay-per-use basis based on energy consumption, which means that besides the fixed daily service charges, customer would only pay if someone charges their EVs at the charging station, and the charge would be based on the energy it consumes. So if no customer charges at the station for a month, then the customer pretty much only pay for the fixed daily charge at $1.2 per day. With that said, here's a quick calculation example. So for a 150 kilowatt Level 3 charging station, if only one customer utilizes the station for 20 minutes within the month, the distribution plus transmission cost on a monthly basis would be $65. In addition, REIT 62 offers the same investment level structure as Fortis Alberta's REIT 61, which may cover a portion of the distribution system upgrade cost that are required to connect the fast charging stations. REIT 62 is expected to effectively help customers with EV charging station economics till customers' load factor reaches 4 to 5%. At that point, when the EV adoption rate in the province of Alberta significantly picks up and more customers charges their cars, REIT 62 may no longer be a more economical solution as compared to REIT 61. The load factor would tend to become more like to REIT 61, and the customer would decide at that point if they would want to move back over to REIT 61. Depends on the charging station data and their economic models. So now, after explaining Fortis Alberta's REIT 62, I'll pass it back to Jennifer to discuss about REIT availability and what to do for next for the EV fast charging station applications.
Thanks so much, Jack. I am very excited that you had to handle that part of the presentation. I know that a burning question with everyone is probably when will REIT 62 be available? So internally, we are working diligently to try and have the rate available for use by Q3, beginning of Q4 at the latest, pending any implementation issues. Of course, not everything gets implemented from an IT and training perspective smoothly, but we are doing everything that we can. So why are we having the presentation today if the rate is not available at this moment? Drawing back on Logan's presentation, the funding program is only available until March 31st this year. And so we want to ensure that applicants have the opportunity to capitalize on the funding because construction does not have to be completed until March 31st of 2024. So let's say that you need to know how much it's going to cost on the distribution side of that, if there are any upgrades required. before you decide that you want to enter into that funding agreement with MCCAC and the South Grow program. What you can do is you can contact FortisAlberta for a budgetary quote for the installation of the charger. What you'll see here on the screen is that there is some information that you can come prepared with to help us quote for that, to give you the best cost for that budgetary. Now, granted that a budgetary quote is only valid for 60 days, and you don't want to accept a quote because construction you don't want to start until the rate is available, but that will give you a good baseline on what the costs are going to be able to install that charger. One of the things that we also have available for you is that when you are doing your siting, a lot of the time these chargers are larger and do need access to 3-phase power. So available publicly are both FortisAlberta's FACE, which is the FortisAlberta Service Estimator, as well as the hosting capacity map. Now, both of these online tools have giant disclaimers that come whenever you're going to use them, and you need to keep in mind that the hosting capacity map is for generation. It is supposed to indicate where if someone was a DER and wanted to produce, could have availability onto the grid. It does not show where there is available capacity, but it does show infrastructure, and that is what you were looking for. So if you're looking for a general layout of your distribution system, both of these tools combined can provide that information to you. So then you don't look at putting it in a parking lot where there's no 3-phase power for forever, and it's going to cost you a fortune to upgrade your power line to get to that location. So that is why we're bringing up these tools. That really concludes the technical part of the presentation, but since I have you guys and you are a captive audience, what I want to do is I want to just make sure that you are aware that FortisAlberta has added some electric vehicle tools to our website. From a residential and ownership perspective, we do have this plugin that shows, generalized vehicles that are available in the market depending on, what your parameters are. It'll give you a comparison of gas versus electric as for costs. And as a kicker, we also did actually add in a fleet conversion tool as well. So if you are looking at converting your fleet, it could give you a baseline of what is going to be the cost you could potentially expect. One of the other things too is that as FortisAlberta works towards this integration of the fleet electrification, of course, we want to study what residential charging does to the distribution grid. So we are actually hosting a smart charging pilot right now. There is information on FortisAlberta.com regarding the pilot. It's open to any residential electric vehicle participant. They do get a $150 kicker to participate as well, and we're partnering with a company called OptWatt. So if you do have any socials that you'd be willing to promote the program, retweet, or if you know anyone within the service territory who is a residential EV owner that you think might want to participate in the pilot to help us with this information in this study, we welcome their application on FortisAlberta.com. That really does conclude the presentation itself. So now we're going to get into the Q&A. So that being said, I am going to enable everyone's microphones and cameras. So you are welcome to join us. And we would like to take this 15 minutes that we have left to answer any questions that you may have between any of the panel participants. Looking in the Q&A, I don't see any written questions yet. So we will get to verbal and Mitchell. I see you have your hand up. And are joining us.
Oh, can you hear me?
There we go.
Okay, sorry.
Welcome.
Yeah, question for is we've looked at a location in our downtown Brooks area. The transmission capability wasn't there, but how closely do the transmission lines actually have to be to, say, the location we're looking at?
Transmission shouldn't be the issue. It should be the actual distribution line or the 3-phase power. And again, location, what happens is depending on how close it is, can really just drive your quote. So if the existing location does not have the capacity, then we would have to upgrade the distribution system to be able to accommodate it. Whatever upgrades are required then gets into that investment portion that, you know, was on Jack's slide. We will invest into the infrastructure, but how much, again, depends on the size of charger you need and how much overall it's going to cost. So your best bet, again, is to put in that location map, like contact fortisalberta.com. You can do it through our contact center, through your stakeholder relations manager, and just let them know where you want it, how big you want it, and we can give you that estimate as far as cost.
Okay, thank you.
Sharon.
Hi, Sharon from the Village of Rosemary. I enjoyed your presentation today. About a year ago, I looked into and got some quotes from companies and tentatively had some funding available from MCCAC. But the challenge I was facing then was actually the rate 61 issues with the demand charges. So it just put it out of reach for us because, I mean, right now we think the uptake would be like one vehicle a week kind of thing, and it's not going to pay for it. So my question is, it's more from, I'm not sure, Southgrow or MCC. The funding was 100% for covering the EV phase 3 or whatever, the size 3 charger, which totally made economic sense. But now it's down to 46. But there were some comments about some federal money that Southgrow had attained. Maybe I missed that part of the presentation because I came in a few minutes late, but I was just wondering what the capital coverage would be or is out there right now for these projects.
Sure, yeah, I can take that. So for the Southgrow program right now, the funding is sourced from Natural Resources Canada through the Zero Emission Vehicle Infrastructure Program, and that's what is offering the 46% rebate through Southgrow. Originally, so last year, the MCCAC did offer a program that was exclusive for municipalities that offered a 100% rebate. That one had matching funds from the provincial government. However, that program has been closed as it was fully allocated. So now it's just a Southgrow program with funding exclusively from the federal government.
Okay, thank you.
Logan, while I have you, I do see that there's a question in the Q&A that asks if Tesla chargers qualify.
No, they don't. They have to have either the J1772 connectors or the CCS or CHAdeMO connector type.
Can I just add a comment, Jennifer?
Yes, of course.
I was just going to add, the 100% funding that was available from the MCCAC was a beautiful moment in time that probably will never come again. So if you're sitting around thinking, well, I'll just wait till there's 100% funding again, that was a very special situation because the MCCAC had some money that they were able to move from a different thing and allocate to that particular program. I wouldn't hope for anything over 50% in the future.
Thank you, Peter. And I guess, you know, I will add to that as well, just in regards to, you know, the reason, again, the presentation today is that, you know, this funding does close as of March 31st. And, you know, to echo the sentiments that we just heard previously, rate 61 was seen as a barrier. So we do appreciate that the rate isn't currently available. While we do work diligently to have it available for customers, that should not stop you from applying and, you know, utilizing the funding that's there, because again, you do have until March of 2024 to get that construction completed, and it will not take us that long to get the rate available. So that, you know, removal of that barrier upfront with the capital that is available to you really could potentially make this a good opportunity for people that had opted out previously. Lenore, I see that you have a question.
Hello. Yeah, I'm Lenore. I'm from the city of Beaumont. So I'm just wondering, in terms of public EV chargers, is it recommended to have a level 2 or level 3? Obviously, level 3 is a lot more expensive. Would it be still useful to put in a level 2 charger for a public EV charger?
We have a lot of people on the panel here that could answer that question. Which one of you wants to rock, paper, scissors for it? We'll go with Rory.
Yeah, I'm welcome to jump in and answer that. So, Lenore, with respect to level 2 versus level 3 charging, while level 3 chargers are an excellent option for providing fast charging infrastructure to EV drivers within your community, typically only 1 or 2 drivers can actually charge at that station in a scenario. So depending on your location and who the anticipated users of that station may be, again, due to the cost and for all the measures and information that Fortis has educated us on today with respect to the rate change and also the transmission, again, you're going to be limited in that sense. Whereas with level 2 infrastructure, you're able to support wider adoption, and again, drivers are going to have more charging ports to actually charge on. Having said that, they are going to be charging a little bit, quite a bit slower than level 3 charging infrastructure. However, depending on the location, it really is pertinent to consider where you are locating the stations themselves. So if drivers are using the stations, there's amenities or services surrounding those stations where this could actually be an economic benefit to your community by putting stations next to local restaurants, shopping retail locations, or gift shops to try to drive activity while drivers are using the stations themselves. So again, to summarize it, it really depends on your use case and who the drivers are you are anticipating to use those stations. But again, for one level 3 station, for example, you can potentially put in, depending on the location, anywhere from 10 to 20 level 2s. So that would be something to consider.
Thank you.
Awesome. Thanks, Rory. We have about 7 minutes left. Amy, thank you.
Thanks very much for this, all of you. I'm from the town of Canmore, and I have kind of a related, but not on the level 3 charger topic. In our work, we hear a lot of hand wringing out there about whether the grid has capacity for a widespread transition to electric vehicles. So I was just curious from the Fortis perspective, if you could speak to the work being done on grid planning capacity, and I'm really interested in level 2 charging. As our community, and we're planning a new development, we would like to require, encourage that all new developments have at least EV capable, be EV capable for level 2 charging, meaning that they all have dryer plugs essentially where there's parking spots. But we get a lot of pushback about, well, the grid can't even handle it. We shouldn't do that. So I was just curious about Fortis' perspective on that. If you have an EV team, I see that there's great stuff on your website, but it's really, kind of consumer focused. Is there what are you forecasting kind of ED adoption along with the numbers that Peter alluded to in his presentation? If you have any general comments, I would love to hear them.
Yeah, definitely. I mean, there's a lot of conversation that happens around 2035. But we have to keep in mind that, 2035 is not the flashpoint, and that the shift is happening gradually. The big thing is that, the country is aiming for net zero carbon emissions in 2050. And then that the sale of only electric cars and light trucks starts in 2035. So, the government itself, has even, I think $1.2 billion to build chargers. Again, we've got the 26 and 27 year targets. So really it's happening gradually, as Peter alluded to, and even his conversation. It's not going as fast as we've seen other things happen, and it is happening gradually. So, it is our responsibility to make sure that supply and demand of electricity is available. And that is, part of what we're doing. So as more customers choose to drive electric vehicles and the demands increase on the grid, this is what we need to do. And our engineering department, as well as, other departments like the Emerging Customer Solutions Department, are looking how we build the infrastructure to be able to meet that capacity requirements. To understand that future load demand and what it is going to do to our grid is various pilots that we've got going on, such as Rate 62. Rate 62, we anticipate, is going to provide us valuable information as regarding adoption, the level of adoption, how fast it's happening, where those charging peaks are going to happen on our grid, and what impact that has. By segregating this customer group now, we'll be able to focus on it better and be able to report on it and use it for planning purposes. And the same with our EV smart charging pilot that we're doing from a residential perspective. So now we have the public commercial perspective, and now we're looking at it from a residential perspective as well. And that is, where are these residential units drawing large amounts of power from the grid? What is it doing locally to those communities and their transformers, and even upgrades to the system? Is there a way that we can accommodate that upgrade without having to have an individual consumer have to pay $30,000 or potentially more to have that larger charger installed into their home? So again, I guess long-winded answer, but we're aware of it. We're doing a lot of things internally to be able to ensure that the grid has the ability to facilitate it and modernize along with it.
So just thanks, Jen. I'll just quickly on top of that a little bit there. So Jennifer talked about the Rig 62 that we created for monitoring the commercial EV charging station utilization and the smart pilot program. So one of our major concern before was that the EV charging infrastructure would create installed at the residential level would create capacity concern for the secondary distribution asset and to the customer's panel. So we did create that smart charging managed EV charging pilot program to monitor that, to observe customers' load usage pattern, and to tend to create something that could send price signal to the customers that could alter their charging behavior to manage the grid impact. And another thing that we are looking at, we are working internally and with external consultant to develop a distribution system roadmap, which we kind of forecasting what it would be the EV adoption rate in the province of Alberta, where are these charging stations tend to locate it at, and then we are going to plan our grid accordingly to optimize manner, I guess. So another idea to that is the EV charging station, whether we have the capacity would depends on where the charging station is located at. So if it's located at a feeder with enough capacity, then that wouldn't likely be a huge of an issue. But then if it's within very high density population areas, then the EV charging station, then the EV charging infrastructures would tend to be managed more carefully to avoid creating any capacity concerns. So just as a conclusion there, like the RIS 62, the managed EV charging pilot program, and the distribution planning roadmap, they would all get us through how we want to respond to the EV adoption rate increase in Alberta.
Can I throw in the non-technical answer? So the way I've had it explained to me before is in 1950, every residential home had a 30 amp breaker panel and a couple of circuits. In the 60s and 70s, everybody went up to 60 amp breaker panels. In the 90s, everybody in Alberta started getting air conditioners, and 100 amp panels were upgraded everywhere, and massive new pressures put on the grid. All the transformers had to get upgraded. Now we're all moving to 200 amp breaker panels. It's being mandated in new residential zones, and folks at the utilities just basically say, yeah, we're just doing the same thing we've always done, and we've got a decade or longer in which to just roll out those upgrades that are needed and figure out the new situation. So don't believe social media. The grids won't collapse. These folks are very smart, and they clearly have a plan, and they're figuring their way forward through the next transition subsequent to the previous transition that we underwent. So that's my non-technical answer.
Again, thank you very much to our wonderful panel participants, Logan, Rory, Peter, for taking time out of your day to join us here today and make sure that this was successful. And I really appreciate everyone's time.